Hey guys, let's wait for 2 minutes. Can you guys hear me? Hello?
Yes.
Cool. All right, I think we should get started. So this is like today is June 1st, 2017. This is the Mesos Containerization Working Group meeting. And just a reminder, this meeting is recorded and will be published and will be published later. So can you guys see my screen?
Yes.
Okay, cool. So I think we have two agenda items today. One is so Dimitri is gonna talk about this design proposal on CPU pinning in Mesos. There's a link to that doc. And if we have more time, we're gonna go through this planning sheet. So basically we have the matrix. I put them into a spreadsheet, and we're gonna track the progress there in that spreadsheet. So if you have more time, we're gonna like trying to update that spreadsheet with status updates. If you have any more items, feel free to add to today's meeting's agenda, or like in the future meetings agenda if you want to talk about something. So this is the tentative agenda today. So I think we should go first with the design proposal discussion from Dimitri, CPU pinning in Mesos. Dimitri, do you want to share the screen if you want to present anything?
Yeah, sure. Can you hear me?
Yes, we can hear you.
So you shouldn't share your screen. It doesn't allow me to do this.
I stopped share. Okay.
You can click on the
Yep.
right top button to exit the full screen mode.
Can you see?
Yes, we can see your screen now.
All right. So.
Well, thanks by the way for presenting this. We really appreciate that, and yeah.
No problem. So it's not a design proposal per se, but rather some initial materials to get started.
Mm-hmm.
So in particular, our interest in CPU pinning is because we found that some of our high-load services run faster if we assign them to Luma nodes. So for us, it's stated here in the ground, like most people are probably interested in memory locality, process isolation, and device locality. Like there was previous work on GPU related stuff. That's like not the current target for us. It's more like we are more like most interested in memory locality and maybe in process isolation.
Mm-hmm.
So why we need this? Like we did some experiments. Like for the memory bound processes, this really helped to improve the performance. There is one interesting scenario where IRQs were pinned to the first 8 cores, and like that was related to network stuff. So this is sort of special configuration for us. So it's not addressed in this proposal, but we're mostly focusing on memory bound processes, which really can be improved with memory pinning. So here is a simple Python script that uses NumPy to sort and generate random numbers. So I did a simple prototype for CPU pinning in Mesos, like just extended CPU set subsystem to do the necessary assignments. And that's what it looked like. So you can see here it's you can gain 5 or 4 seconds. You can run 5 or 4 seconds faster. And the critical parameter, which demonstrates that the memory was used from the local node. Like you can see like huge benefit here. So that's why we're interested. I also collected here some of, yep.
Okay, so can I ask some questions? So you're saying that, so I see like there's a huge difference in terms of like no load misses. What is that? Is it like a cache miss or some?
So basically, if you have a processor which contains several cores and 2 sockets, like the memory, if you access memory on which is local to another node, it has to travel through bus and all that stuff. So it's really slow. But if you can access your local memory, like you have the direct connection, CPU has direct connection to it, then it works faster.
I see, but yeah, my curiosity is like, what does this no load misses means?
It's the perf. When running perf, it shows the statistics. Basically, it means foreign memory access.
Foreign memory access. Got it. I see. Okay.
Hey, Dimitri, quick question.
Yep.
Can you get that metric from the perf support in Mesos for your tasks?
I am not quite sure. I was just running perf in parallel with my workload.
Okay, thanks.
So I've collected some related Mesos tickets. Unfortunately, most of them are idle, no activity there. This implementation here from GitHub, it's focused on GPU locality. I don't know if author is here. Yeah, probably not. So that was some really specific approach, and I'm not sure if it would work like in general case. It's definitely not working for us. So that's why I started.
I see. Can I ask another question? So you mentioned, can you go back to the top? I think you mentioned you guys focus more on memory than CPU. Is that because the workload you guys are running are like things like a cache?
Yeah, it's cache.
I see.
Basically, and some other workloads which are also memory bound.
Okay.
We maybe have some interest in process isolation, but that's kind of tricky situation because if you like assign all CPUs, if you assign process to just subset of CPUs, then this process cannot burst, and that could be an issue. So I'm not sure if you want this or not.
Yeah, I think like this is like another discussion that we can have, especially like I think Kubernetes has that discussion. I think you have that link in the doc.
Yeah.
I think it's really interesting to understand like what their rationale is. I go through the issues, GitHub issues today, and also their like notes in their face-to-face meetings. There's a lot of interesting notes there. And by the way, we should take notes. Who's volunteered? Who can take notes? Gilbert, can you do that? Like maybe like take some notes. Hello, Gilbert. We cannot hear you. You're muted.
Oh, yes.
Yeah, I mean, if possible, can you take some notes? Just capture the discussion, so
yeah,
that
sure.
like everyone else can see. Although we have recording.
Yeah, sure.
Yeah. So, for process isolation purposes, this could be interesting for some people. Like you have guaranteed CPU access, and there are no noisy neighbors and like other benefits, but you cannot burst. And this could be okay for some.
Yeah.
Yeah, but I haven't investigated this in particular, so I cannot say anything. Just what we have is
okay,
cases for memory locality.
So it sounds like this doc title should be like a memory pinning rather than CPU pinning. Somehow, might be based on the content of this talk.
Well, you still have to be pinned to CPUs which are local to the memory that you use.
Yeah, but the goal is trying to. I see. So the goal is trying to put the workload close to the memory node.
Yeah. So CPU sets have an option to migrate memory. So if you're assigned to one NUMA node and you for some reason migrate to another NUMA node, then the kernel behind the scenes can migrate the data from one node to another. So I'll continue with the links. The last ones, it's for people interested in GPUs. Yeah, I don't know much about this, but basically this also relates to CPU pinning because device is also connected to some NUMA node, to some socket, and you can, like if you need really fast access to this device, you would be interested in pinning to that node.
Yeah, I think it's not just for memory. I think it's also for GPU. GPU has this topology too. Like I think Kevin is here too, so he can comment on more on this one. But I think it's not just for GPU or memory. It's also like, for example, like maybe in the future we have some other devices that you have some like a heterogeneous activity in the device, so that you have different speed when you're accessing the device from different CPU node. So okay.
GPU is just probably the most common case.
Yeah, GPU is the most common one.
Yes, about the existing systems, I checked Kubernetes, and there was a proposal to sort of expose CPU affinity masks, and people with work experience opposed to that. I'm also not a fan of this because, well, it would be difficult to, like, if your system is running and tasks, when task is finished, you have a gap in, basically, you have a fragmentation of CPUs. And now this becomes difficult. Like you need to defragment it and how to expose these resources to the framework and all that stuff.
So the main complaint from Borg people is the fragmentation?
No, they said this is too low level. Like, you have less control over this when you do things like this. What they wanted basically was some high-level requirements, like you express the intent, like I'm a latency-sensitive services, or I'm a memory-bound service, or I'm compute-bound service. And then, based on this, the system should decide what it should do. Like if it's like memory-bound service, then it would probably benefit from pinning to a single NUMA node and things like that. So that you don't really, as a client of the system, you don't really deal with low-level stuff like affinity masks. You just express what you need. Yeah. So it seems that like they had a discussion captured in this document, like some sort of community meeting, and I guess they came up with this proposal based on this.
Yeah, I look at that thread, especially the first link that you posted, and I saw that thread, just the discussion in that thread. I think the main pushback from Borg people, the main reason they push back on that is because they think, I think the ticket is about like exposing CPU set of Docker parameter, like basically like some people want to say, hey, when I launch a pod, I can say dash CPU sets equals to what, so that they can ping a workload to a given given CPU. I think the pushback from Borg, the reason is because they don't want to expose that low level of control because they have some optimization in mind. For example, Borg does something very smart. If they expose CPU set information in the API level, then they don't have the opportunity to do those optimization in the future. And based on their experience, they said it's better not exposing those in the API level, and they will figure out how to do that later. I think that's the main pushback from the Borg people, as I understand the thread of discussion. The first,
I also highlighted the paragraph I found in the meeting notes. So that gives some insight on what they do. Like they collect some statistics, I guess, and based on the behavior, they do some decisions in the system. So at some point, this probably could be automated, like you just give some hint or like describe your QoS class, and then it just works. That's why I didn't read through all this document, but tried to like grab some relevant points.
Yeah, so it would be great that you can like go through that documentation. I think that document, I skimmed the documentation, especially the notes from their face-to-face meeting. There's a lot of interesting point there. I think we should do a synthesis of like what are the points. I think they mentioned some concept very in line with our resource model. Like they're discussing like resources, classes, things like that. So it would be great to have a synthesis of that discussion somehow, because I think it's really very relevant to this discussion. And always it's beneficial to learn from others. So I would suggest like let's do some exercise to go through their notes and their issues to figure out what are the exact argument like against this, and what are the like what their proposal solution is. And then we can have a discussion, see how well this can be fit into our model of resource management. I think that's my kind of suggestion here.
Yeah, unfortunately, I don't have Kubernetes experience, so yeah.
I see. Are you guys still pushing for this? Like, I know that the problem you guys are trying to solve is for some cache workload. You want to make sure their performance is like very good performance without like interfere by other nodes. Do you care about interference, by the way, for those like?
Yeah, for those workloads we do, and like this run on dedicated cluster, so The only interference comes from the same sort of tasks.
I
So
see.
in this case, it would work. If we assign to NUMA nodes, then it would work better.
Yeah, so sounds like there are multiple issues here. So first of all, I think you care about locality because you want to make sure that the workload are placed on those CPU node that close to the memory node. And I think you also care about CPU interference. Do you want you don't want the CPU used by those cache services being used by some other services? Is that something that you guys want as well? Like dedicated CPU cores, so that you don't allow other tasks to burst into those cores.
That's not really the case because this cluster runs uniform workloads.
Okay, so you guys don't want that. So it's okay that some other workload bursts into those cores, potentially affecting some of the performance of those cache services, but you guys are okay with that?
Well, we did testing with exclusive CPU pinning. No one else was using these CPUs, and the interference.
No, I think it's about,
relevant.
Yeah, I think it's not about the cache service itself. It's about do you want to make sure that other services running on the same host not be able to use the CPU cores reserved for that cache service? Do you want to guarantee that or not?
I think yes.
Okay, so you want both. You want memory pinning? Okay. Yes, to me, this is a separate issue. It's one is the locality, how do we place, how do we expose the topology information? And the other thing is how do we make sure that the CPU, how do you reduce the interference, making sure some resources are dedicated, no one can burst into those resources. I feel these are two separate issues, but I could be wrong. Anyone else has any opinion on this one?
Yeah, they sound like separate to me just because, while you might solve that first one, having you could use CPU sets such that you're not actually dedicated on those cores. It sounds like maybe what is being done for Dimitri is they're running on dedicated hosts for a particular service, and so they're kind of avoiding that problem of interference where someone bursts into the core. So you might have a different solution for that problem.
Yeah, in my experience, the cores were assigned exclusively to a process. So basically, I was running 4 processes on 2 NUMA nodes. Each process was assigned to half of NUMA node, and well, that was running pretty good. So the only interference that was possible is from the operating system or some other stuff running outside of the container.
Right. Is that because for you guys you're using an approach where in your scheduler you ensured that only that service lands on that host?
Yeah.
Okay. Got it. And do you have any thoughts on within the container? Let's say you have 4 cores within the container, ensuring that for those 4 cores, the container's not interfering with itself. Are you binding processes to cores within the container? Or are you just letting them use?
So there was just 1 process per container, and
okay.
Yeah, and it was exclusively using the cores.
Okay.
Well, exclusively is probably the wrong word because basically in CPU sets under Mesos hierarchy, it was the only one using it, but other processes running on the host could use that core.
Right. Okay. Yeah, I mean, one thing that would be helpful for me when looking at something like this is the use cases. I actually was guessing that this would be more low latency workloads like a cache or high frequency trading or things like that. So, it turns out that looking at this doc, there's actually some memory throughput workloads as well. So it would be kind of great to capture those different use cases where people want this kind of feature. I don't know if that's helpful for others, but it helps me understand like what we're enabling by doing this.
Yeah, I think that makes sense. I think the other thing is I kind of agree with Borg people is like probably exposing CPU set itself is too low level, and that like prevent us from doing like some future optimization if possible in the future. Like I feel like we should think about like how do we expose that in the API level rather than just expose that low level CPU set directly to the users. So that's my kind of feedback, and I think one of the things that we should definitely do is trying to look through those notes. I think those are really valuable notes, and trying to figure out like what are the thoughts those people has, and see if we can borrow anything from them, and what makes sense for us in our model. So that's kind of general kind of recommendation on this.
Mm-hmm.
Does that make sense?
Yeah, sure.
Okay. Cool. Do you have anything else on this doc? Pros and cons?
Yeah, so it's just general ideas about pros and cons.
Okay. Do you have like any suggestion, like what the approach should be? Like your suggestion on the approach? Like.
I kind of agree with Borg people.
Yeah.
Like we should have some high level thing, because I tried implementing this, like doing small prototypes to see how it runs. So one thing is like CPU set resources, just exposing CPU set CPUs as resource. I did this because it was very simple to do. I don't think we should follow this path.
Okay.
But it works if you have uniform workload and you don't want to change your framework, but you really want to use this, then it works. And then if you have different workloads, different machines in cluster, then you're in trouble. Then the next approach is it's kind of different type of extreme. Like you can use constraints to describe what you want. For example, you could say, I want to bind to 3 CPUs from single NUMA node. And the system inside like figures out which CPUs this should be and how to balance workload on the machine to fit these constraints.
Can you elaborate on this affinity info? Like what's processing unit?
So basically, you can say, I want to be pinned to some of the processing unit, like single thread in the hyper-threaded CPU, or to single core, or to land on a single socket or single NUMA node. In most cases, this probably would be just the same thing. But,
I see. So system means I don't care.
Yeah.
Okay.
Then you basically say from which unit you want to select units for assignment. Like if it's from system, then you can land on any CPU. Like if it's from single NUMA node, then you will use only CPUs on that NUMA node. For example, this allows scenario like you want to bind to half of NUMA node and use this course exclusively.
I see.
Yeah, then this is just, I haven't implemented this, but this is just like how we can expand this idea. Like for compute bound processes, you might want to use cores from different nodes. And then you say, I want to distribute my workload across NUMA nodes.
I see. So one question I have here is, so where do you put that affinity info? Inside resources or inside container info?
It's container info.
Okay. So one question I have is, how does that affect allocation of the resources? Does that mean that the allocator needs to be aware of those topologies so that when it makes allocation decisions, it needs to take into account those kind of additional things?
No, there was no changes to allocator. So it's working based on CPU's resource, and that's all. But then when the workload lands on some node, CPU set subsystem does all the job. Like
okay, you're saying like sorry.
Yep.
Go ahead.
Yeah, so it looks at the affinity info of all containers on this system and tries to balance them. Like if there are free resources that are satisfying these constraints, then it just assigns CPUs and that's all. If it couldn't do this, then it needs to rebalance. Like probably like if it tried to try different assignments of processes to nodes, then it could find a solution. But the problem is that this is actually a bin packing problem, which is in p-hard.
Yeah,
So,
yeah, okay, I see. So you're saying like it's not an allocation problem because like allocator don't aware of those things, but the isolator, like whatever, like the agent running on the node will need to figure out the placement based on those constraints, and it's an NP hard problem to solve that.
Yeah, it works for small systems because like if you have 2 NUMA nodes, then it's really easy to solve this. But for large systems, yeah, there is a limit. It starts to work slowly. I tried heuristics like best fit, like assign process to the node which has more, which has after assignment, which will have less free CPUs after assignment. But you know that's not an exact solution, and it could fail sometimes when the exact solution exists.
Another question I have is like, is it always possible to find a solution, or like, is it possible that there's no solution?
No. It could be the case when there is no solution like this one.
Okay, how do you deal with that case? If there's no solution, like you cannot find a placement to satisfy all these constraints.
Yeah, so for my prototype, I just failed the task.
I see, and you rely on scheduler to reschedule the task to a different node so that hopefully that can be solved. Got it. Okay. Yeah, that's a little unfortunate. The fact that I don't know what the solution should be, but this is a little unfortunate. I wish like this kind of constraint can be surfaced to allocator, and then when allocator make those kind of allocations, take those things into account. But I'm not sure. Like I'm just throwing ideas and comments here.
Yeah, given that it's an p-hard problem,
yeah,
that could be an issue, and you'll have to update when task completes. This means that like you can rebalance the tasks that are already on the node, like to free one node for other tasks. And this gets complicated.
Okay.
So there's another dimension I think in this binding stuff, which is IRQs and network resources. So one of the reasons I thought about Dimitri's notion of distributing across NUMA nodes and why you'd want to do that. Well, one of the reasons you would want to do that is because you have network cards bound to NUMA nodes. So if you're going to express topology in this very fine-grained manner, I think one of the things you want to express is I/O resources as well. So you want to, maybe you can conceptualize having a task which is distributed over NUMA nodes that does very high performance packet processing, in which case you want to bind the network resources to the same NUMA nodes. And so if you can't express that you probably want to express that within this framework as well, so that you don't have to have like magical out-of-band handshakes.
Yeah. So just to summarize, like this approach could be like extremely hard to support in development, just because of the complexity of impact.
Yes, I agree with that. Another question, Dimitri, is did you look at what did you think of the CPU sets isolator, which kind of tries to do this automatically?
Sorry, James, what's the CPU set isolator? What does it do?
There's a link to it from Dimitri's document here. It's
Okay.
the one that was posted previously to the dev list, and I've only glanced at it briefly, but he tries to basically it's an isolator that tries to automatically look at the topology and pack tasks into CPU sets and automatically pin them to cores or nodes.
If you're referring to this GitHub link, right?
Yeah. Yes.
Yeah. So as far as I understood, it was like trying to solve some problem to find how many resources it can offer, and then expose them as oversubscribable resources. And then, like, then this could be used by whatever framework was. But well, I didn't like this solution actually, because it seems like non-deterministic for me.
I see. It would be great to have it would be great to have some background on like what they did, especially like I don't understand what they're doing. So James, you say you kind of take a look, but haven't dig deeper into that.
Okay.
Are they doing the allocation? Are they doing the allocation? Like for example, like they do CPU set assignment based on what? Like based on nothing or some actual labels?
No, I think I haven't actually deeply looked at the code, but I just more glanced at it and read the README. But my impression was that they look at the resources used by the task, and they rule of hand wavily kind of go, hey, this task needs like 2 CPUs, so I'll find 2 unpinned CPUs and pin to 2 CPUs.
I see. So the assumption is
the idea is to using what you know about the task resources to automatically pin to specific hardware resources. So you're probably not going to get as strong results as if you're expressing something directly from a scheduler, but maybe you would automatically get better results overall.
Yeah, I think that idea I saw. So yeah, that's interesting. I think I saw that idea from the Kubernetes nodes. I think one of the ideas is like the node will figure out the assignment magically based on some signals, and that signal can be any hardware counters or whatever. And they don't allow. Sorry, I have to move to a different room. I'm being kicked out. Oh, okay. Sorry about that. I have to move to a different room.
Thank you.
All right, sorry about that. Yeah, I saw that discussion. That like one approach is like asking the node to figure out magically the assignment of those cores, maybe based on some like high-level hints from the user, like quality of service, QoS classes, things like that. But I think that's approach that Borg took as well. Based on my understanding, is Borg does something similar, but based on some signal from like some other signals. I don't know what that signal is. So maybe interesting to see the Borg paper to figure out what exactly or maybe chatting with Borg people, maybe if that's possible. I don't know what they did, but that's one approach to solve the problem. That like instead of like letting user pick, the system just magically pick and do the assignment based on some heuristics. And the downside for that is you don't have predictability, so you're not guaranteed anything. But in most of the cases, the performance should be okay. And then you have some benefit, but the downside, you don't have predictability trade-off.
Yeah, I think the other downside to that is you're not able to implicitly oversubscribe CPU anymore. I know for our deployment, we basically give everybody we give most tasks very small amounts of CPU from the resource allocator, and assume that it's okay for them to burst into any spare CPU that's not actually being used.
I see. That's what you guys did. So you guys didn't turn on. Okay, I see. So you guys didn't turn on like CFS?
No, we don't. Most microservices are idle most of the time.
I see. Got it. Yeah, I think that's some interesting things I find out from the Kubernetes node as well. Is I think their like oversubscription story is very different than our oversubscription story. So I think in Mesos we have this oversubscription support where we have a resource estimator that can send out additional resources beyond the available resources on the agent based on the usage of the container, and allow framework to use those resources. But the route that Kubernetes guys took is kind of like purely rely on kernel to do that, especially for CPU. They define 3 classes and like basically say, if it's a best effort, I can set the CFS quota for the best effort task, but I set a very small share, but they can burst into using a lot of CPU if there's no workload using on that box. So basically rely on by tweaking the C groups control like CPU shares and the CFS quota to achieve the oversubscription, which is very different than our approach of solving oversubscription problems, but it's kind of interesting.
Yeah, I think there's an argument to be made for a class of tasks which requires a pinned, if the class of tasks which requires pinned and dedicated CPU resources, and there's a separate class of task which is a lot more fuzzy and hand wavy about how much they're actually going to use and whether they really need it or not right now.
Yeah, I think like someone mentioned another an idea is trying to have 2 pools. One is dedicated pool where you have exclusivity on your CPU cores, and the second pool is like a shared pool where everyone can burst into each other and interfere with each other. I think someone mentioned, especially when Borg people mentioned that they did that at Google and they very regret on that, and they desperately wants to revert that. I don't know why. They didn't mention why, but that's what they say. That's what I saw in the notes, which is kind of...
Yeah, this sounds very similar to the problem that Dimitri is addressing with these different proposals, right?
Mm-hmm, yeah.
So I wonder, Dimitri, how far do you think you could get if you were able to express just the difference between a task that requires, like just to say, if you had something really simple like a flag to say this task requires dedicated resources in some sense, and then the isolator was able to look at that and automatically do some pinning, as opposed to a task that was happy to just get fungible resources.
Yeah, that could be relatively easy done, but I don't have requirements from other people like this idea with distribution. I don't really have a use case for this. I mean, what we really need is packing processes tightly into NUMA nodes, but maybe someone else has different use cases. And if this is the only case, then you can just have like one flag or class in the task, and that would act like a hint that this should be packed into NUMA nodes.
Yeah, I think we do have a use case for GPU where that we want to somehow expose the topology information. Because for GPU, like if you use 2 GPUs over a PCI bus, it's going to be really slow compared to some like it's very similar to memory. Like you have some topology of those GPUs, and if you use the 2 GPU close to each other, that will give you a lot of performance improvement than 2 GPUs connected by PCI bus. Things like that.
Yeah, this could be expressed like by device affinity.
Yeah, I mean, my question is, can we generalize this, or like we treat them as separate issues, like CPU has a separate issue than GPU, or like we treat them generically so that we don't need to do that for every single resource we can come up with, because people can come up with like IO, or maybe you think that generalization of that is too much because it's very hard to generalize because these different resources have different characteristics, and it's hard to generalize. So that's kind of the question that I want to address, see which one is the better route for us.
I mean, the way that I was picturing it was to send along whatever topology information we could. I don't know what the format would be, but I was picturing sending that along with every offer. And then you could have a scheduler sort of make some decisions about what it would prefer to, where it would prefer to schedule the jobs and what specific resources it would want. And if the scheduler can't honor that, then, we'd have to deal with that separately.
Yeah, but I think another question, so Kevin, I think the issue is that is like the Mesos needs to make allocation decisions as well. Like when Mesos is making allocation decision, how does our allocator make such a decision that give one framework resources has close topology?
Sure. I mean, that's obviously a complication. I was picturing this more in the framework of once we had something like optimistic offers. So if you put a request in, then it could get denied, and then you get another offer to try again.
So one interesting thing about GPUs is that we're basically doing device level allocation already, right? Like we don't let you consume half a GPU. It's not a fractional vector like CPUs are. The only thing is that effectively the decision about which GPU we give you is occurring in the isolator right now. And if there's different cards on a machine, that might not be what you want, right? You might want a specific card that matches your workload, but you can't currently choose which card, right? Because we're doing that in the isolator. So maybe for GPUs, it makes more sense to be exposing like, hey, this particular GPU device is this, it's connected to this other GPU device with an NVLink. You can pick both together if you want to communicate over NVLink, which is faster compared to CPUs where, we want people to be able to take like 1/10 of a CPU. And, they often don't care about which core it is because machines they don't tend to have heterogeneous cores, right?
Yeah, so Ben, are you saying like the device assignment for those GPUs can be done at the node, like agent side?
Right now it's done at the agent in the isolator.
I see. So, and then we can do smart logic there to make sure that when a task asks for 2 GPU resources, make sure they're close together somehow.
Well, we could try to do that, but the thing is the scheduler is not going to know whether we are able to or not, right? Because sometimes we won't be able to succeed depending on what we already are running.
Oh yeah, of course. I mean, I'm just talking about like this is something that we can do for sure. Like it's pretty straightforward to do. Like,
yeah, but the scheduler needs to know, right?
Information to the scheduler. Yeah,
I agree. The scheduler,
yeah, I agree. If scheduler wants to know that information and do more smart logic, then we have to expose that information.
What I mean by scheduler needs to know is that the workload depends. A lot of workloads require an NVLink connection between the 2 GPUs they choose because otherwise it takes many orders of magnitude longer to run.
Yeah, for the MVP, we kind of ignored this because most workloads we looked at they either wanted 1 GPU when this doesn't factor in, or they wanted all the GPUs, which means they're getting all of them anyway. Some of them are connected by MV-Link, some aren't. But once you move to, you know, having lots and lots of GPUs on a single machine and people want to divvy that up amongst their applications, that's when this really starts to matter.
I see. Okay. Okay, I think we only have 10 minutes left. I think that's a good discussion. I'm not sure how good the notes are, but I think that the action item is, Dimitri, I think my suggestion is we should definitely look at those notes that you post, like the links that you posted, especially like the discussion that those guys in Kubernetes community has, and see if we can synthesize those discussions into a kind of a doc, so that everyone can digest what their solution is, what their proposal is, and then we can move from there and see what's the best for us. I think that's my proposal for solving this as a first step. And I mean, it would be great to list like the pros and the cons, like they think for each potential proposal they have right now. That's my proposal. I'm not sure what do you think on this.
Yeah, I think if people could share their use cases that they have, also be useful.
Okay, yeah, I think another thing that we should follow up is like collecting all these kind of use cases that I think we have a concrete use case for GPU, and you have a concrete case for CPU Newman node. And if anyone has any other use cases, feel free to, we should create a doc and collecting those use cases. Maybe create a Jira ticket and collect those use cases in the Jira ticket, so that we know like what are the problems we are trying to solve, and see if we can come up with a solution, and based on those discussions that we kind of borrow from Kubernetes community, which is good. Does that make sense?
Makes sense to me.
Cool. Okay, so sounds great. So we have 7 minutes left. I do want to, so thanks Dimitri for sharing this. Really appreciate that. I think we have like 2 follow-up items. One is collect use cases. The other one is like trying to synthesize what the discussion inside Kubernetes community regarding this topic, and see what the options are. And we can go from there. Cool, so I'm gonna share my screen. Actually, we have 7 minutes left. Let me share my screen. On the, can you guys see my screen? So I create a Google Doc here. So basically, like the thing we did last week, that we have all these features that we want to work on together, and I kind of synthesize those into a spreadsheet, so it's easy to track. I try to like have the status here, like what phase this feature is in right now, like design phase. Like I have 4 right now, like not started, in design, in progress, which means you're in coding, and then done. So I try to figure out what the current status is. You feel free to update the doc if you think the status is not correct. And I think this is what we discussed last time, urgency and effort. And if you have a target release, do put the target release there so that we can reprioritize if possible. And I do have owners and reviewers here. So this is like for me and for us to track who is working on what. And this is based on the discussion last time. So I think one thing we should do is every working group meeting, let's go through this doc, see what are the status of those things that we are trying to do, so that everyone is on the same page. I think which is good right now, like CPU affinity, we're in design, and we just have a discussion today. And if you want to join like one particular feature effort, feel free to put your name there and contact the owner, the existing owner. Since we only have 5 minutes left, let's do the top.
What about adding comment column to this document?
Document? Sorry, what do you mean?
I mean, what about adding comment column? So we could more broadly update the status of the issue, of the feature.
I think that would be pretty useful. A lot of these features I see, it's not clear to me what they mean. Like the netlink sockets one could use a sentence to give some context.
Okay, I see. So I think what I plan to do is I try to have a link to a Jira tickets if possible for those items. If not, I'll try to add some description there if there's not existing Jira ticket. But I think ideally we should have a Jira ticket for each of those items so that we can have a description there, like what that is, why it's important, things like that. Like I think the owner should, like maybe the owner should update this doc to have a link to the Jira ticket. I'm pretty sure most of the items we have a Jira ticket already. There might be some Jira, like some issues don't have Jira ticket. I can try to do a pass before the next meeting to have a Jira ticket if possible, but I want you guys to, especially the owners, if you're working on that feature, make sure to have a link to these, like the description here. Make sense? Okay, so I'm not sure Zhitao is on the line. I'm just trying to go through this doc. I think the second item, volume ownership group and group cleanup, I think I chat with Ilya and he agreed to do a presentation next week. No, sorry, the next working group meeting on this topic. So so see what we can do, especially do some background analysis and see what we can do to clean up the volume group ownership issues. So I would say it's in design. It's started. Documentation. So Gilbert, what's the status of the documentation? Are you still working on that?
I have a couple patches which is discarded, but I can reopen them and which contain the explanation for each isolator, and there's a metric for all the isolator. We currently have almost around like 20 isolators in our code base. So yeah, that's my plan, to reopen those review patches and see if we can ship it for 1.4.
Okay, so you're still working on that. Do you need help from anyone else? I think Tobias and some other people offer at least offer help on review those documentation. You should
I think we can break the documentation into an epic and then make it as a separate a couple other Jiras, so different people can pick up different items. So which I can definitely help on sharing.
Okay, so so you're still working on that one. So so you still want to work on this one. Okay, so mark it as started. So once you started, just mark that as in progress. And
yeah, sure.
Someone already offered like a review your documentation. Please reach out to them.
Yeah, sure. And cool. For the image layer GC, so I talked to Zhitao recently. We're gonna have a sync like 6 hours later, and then we break the different implementation into pieces so that we can have a different progress on which state we are currently in. So, but for the whole feature, we still target for 1.4.
Yeah, I think another thing that I want to mention here is like I think Chen who is working on OCI support right now is also interested in that one. So maybe like you should collaborate with Chen as well on this one. Because he needs to do the same thing for OCI as well. I mean, maybe it makes sense to just consolidate with the OCI implementation. So maybe chat with him. Yeah,
I will push Chen into the loop.
Okay, yeah, just make sure like put Chen into the loop because he's working on the OCI support right now. Cool. So I think we just chat about CPU affinity. We have some action items. It's in design. That's good. Support private registry and Docker credential helpers. Have you chatted with Mao, Gilbert? I think he's not on the line. I can ping you. What's the status there?
I did not have a chance yet, but he provided a link to a GitHub repo. I did not have a chance to look at that repo yet.
Okay. Okay, we have some message. Okay, so I think we are out of time. I think that's. I'll reach out to some of the people for those high priority items and see what's the status there, and then trying to update this doc. And I'll take the action item to have a link as soon as possible for those items so that everyone is on the same page. All right. Thank you very much for the discussion today, and it's really great. And I'm so happy that you guys can join this meeting, and hopefully to see you again next time in 2 weeks. All right. Thank you very much.
Thanks.
Thank you.
Yeah, thank you. See you guys.
Bye.
See you.
Thanks. Bye.